In the second module of Understanding the Agrobiology of Agrochemical Formulations 2, we will consider applied aspects of insecticide formulation. We begin this module with essential definitions of insecticides and nematicides. Before moving on to differentiate between contact insecticides, translaminar insecticides, and systemic insecticides, including their respective benefits, challenges, and opportunities for formulation. From this overview, we move to looking at how contact insecticides, systemic insecticides, and translaminar insecticides move into the leaf and what this means for which specific insect types are targeted by these active ingredients. We consider the insecticidal modes of action and do a deeper dive, especially into the nerve or muscle inhibitors. And we close off this part by building up an overview based on information extracted from the pesticide properties database, the ePesticide manual, and the reference manual for agronomic advisors, grouping the respective active ingredients into their physical chemical characteristics, their systemicity, and their activity. This will allow us to build up an overview or a resource which brings together the active ingredient characteristics and the characteristics of the insect pests which we are targeting with our formulation and adjuvant developments. The important active ingredient characteristics for active ingredient bioavailability are covered in the previous course, Agrobiology of Crop Protection Formulations 1, and include the solubility of the active ingredient in water and or in solvents, as well as the melting point of the active ingredients. Here we will see that this determines which formulation options are relevant for our specific active ingredient. Integrating the active ingredient physical chemical characteristics together with the physiological characteristics of systemicity in the vascular system of plants, we combine the pKa and the log P of the active ingredient to predict the systemicity of the active ingredient. By combining the content of the previous course as well as the previous slides in this module, we can build an overview to allow us to predict which formulation types will be relevant for specific active ingredients based on their physical chemical properties, as well as which adjuvants will typically be relevant for optimizing bioavailability. Finally, we will be able to combine the content of the previous slides and build up some reference overviews which will provide an easily accessible reference for specific classes of active ingredients on the basis of their physical chemical characteristics, their mode of action, leaf responses, classifications, activity against insects, formulation options, and adjuvant options. To close off this module, we will consider two case studies. The first for pyrethroids, where we will consider the importance of kinetics of active ingredient uptake, the advantages and disadvantages of rapid active ingredient uptake and rapid kinetics, and how we can use formulation and adjuvant options to adjust the availability of the active ingredient. In the second case study, we will consider the active ingredient spirotetramat, which is an active ingredient which it has neither particularly high water solubility nor solvent solubility, and we will discuss and consider the issues related to this, the specific challenges, and how these can be addressed again with formulation and adjuvant technologies.